Okay, at the start of this video, we want to review for you just a couple of algebra equation solving techniques that are going to come up in just a minute when we work some trig equations. And we actually looked at something very much like this in the last video. But remember to solve an equation that has something squared and like a number term or a constant term, but no something term. You know, something that doesn't look like this second equation here that has, you know, n squared, n, and a number. The easiest way to solve this is to just get the thing squared by itself. And then you can, like we did in the last video, take the square root of each side and say that x can be either positive or negative 2. Either option is acceptable. So that's the best strategy if you've got something squared and a numerical term. But if you've got both the squared term and the n term, or the term to the first power, you need to do some kind of quadratic work. You could factor, you could do quadratic formula. Your best bet, if you ask me, is to hope that the things will factor, and I believe you could show that the left side of this equation does factor. Another good thing to talk about while we're sitting here working on something like this is remember that the technique we learned in algebra for solving a quadratic equation by factoring only really worked if we had the quadratic set equal to 0. So this was a vital step. I can't really do the same trick from here if I don't have the quadratic set equal to 0. But this one actually does factor. N minus 2 times n plus 1 gives me the same as this expression. And then, of course, you set each one of those factors equal to 0. If a product equals 0, then one of the factors has to be 0. And I would get values like 2 or, in this case, negative 1. So probably nothing new or earth-shattering here, but we just wanted to remind you of that technique because I think you're going to see that structure show up in just a minute. So let's look at an equation like this one here that says the tangent squared of x minus 3 equals 0. And we actually already solved one similar to this in the last video, but let's just, for efficiency's sake, see what we can do here. You know, I've got a something squared, and I've got a number term. The easiest way to solve this equation is going to be to isolate the squared term. So if tangent squared of x minus 3 equals 0, that means tangent squared of x has to equal 3. And at this point, I can take the square root of both sides. So the tangent of x could equal, it could be square root of 3, or it could be negative square root of 3. And I need to make sure that I get both of those options in there. Okay. One more look back at the unit circle on where I could have a tangent of square root of 3 or negative square root of 3. Erase some of my markings here. So we're looking for tangent to be either positive or negative square root of 3. Let's see, well, y over x, one of them is here, square root of 3. We also decided, and we actually worked this I think in the last video, that this angle here would give me a tangent of square root of 3. But there are a couple angles where I would get a tangent of negative square root of 3, like 5 pi over 3. Negative square root of 3 over 2 divided by a half, well, the 2's would cancel, but I would just be left with negative square root of 3 over 1. And I think 2 pi over 3 actually works here too, because the 2's would cancel, and I would get square root of 3 over negative 1, and of course that's negative square root of 3 as well. So I'm going to list those options as my answers here. There are actually 4 options here. Students often will ask me, do I need to list these in order? No. It's not a bad mathematical thing to do, but you wouldn't be wrong to list a set that's not ordered. So here are the 4 values that we found on our unit circle, and it turns out that any one of those values solves this. It's worth pointing out a way to check yourself is to plug these values in for x and see if you don't end up where you started. You know, if I plug pi over 3 in for tangent, and this is just an example, I could check all of these this way. So the tangent of pi over 3 squared minus 3 ought to be 0. Sometimes when you're checking an equation, you'll put a question mark over the equation to say, is that right? And if I go to my unit circle, I can show you that tangent of pi over 3, like we found a second ago, is indeed square root of 3. So we're asking, is the square root of 3 squared minus 3 equal to 0? And of course it is. So So it's worth checking, at least mentally. I'm not sure you have to write it out, but it's worth checking your work. Let's look at something like this. We want to solve this equation on the interval of 0 to 2 pi, and the reason I want to show you an example like this is I want to show you, you might even write out now as you're taking notes here, don't do what you're about to see. The most common student mistake here is to see that there's a cosecant as a factor of each side and just divide it out. No big capital letters with about 17 exclamation points. Don't do that, because if you do that, you're eliminating some possible solutions. You're eliminating any values that you might get from working with cosecant, okay? So let's undo that. Don't do that, okay? But what I do want to do is to try and get this thing maybe set equal to 0. I'm going to do some factoring here, but to factor it really helps me to get everything on one side with 0 on the other. So what I'm going to do is I'm going to take this term and I'm going to subtract it from both sides. So we can now say that secant of x times cosecant of x minus 2 cosecant of x equals 0. That's a better idea because now I can maybe do some factoring and set some things equal to 0, and I can actually factor a cosecant out of each term. So I can say that the cosecant of x times what's left over, it's the secant of x minus 2 equals 0. And at this point, you've got that old algebra trick again where you've got two factors that are multiplied together set equal to 0. So that tells you that one of them has to be equal to 0. Either cosecant of x has to be equal to 0, or secant of x minus 2 has to be equal to 0. So I'm at a point where I'm looking for a couple of things here. I want to know where the cosecant of x equals 0. You know, I'm thinking through here, and if the cosecant of x is 0, that tells me that the sine of x would have to be its reciprocal, right? But what's 1 divided by 0? Well, it doesn't have a value. It's undefined, right? Well, it turns out if I look at my unit circle, there aren't any places where the sine of x is undefined. Sine of x has a value for any input anywhere, especially between 0 and 2 pi. So there are actually no solutions to this. I don't get any values from this. This is, you know, there's no values here. No values of x make this true. But I should still check this here. So if the secant of x minus 2 equals 0, well, that tells me that the secant of x is equal to 2. And using the same reciprocal idea from before, if I want to know where the secant is equal to 2, really that's telling me where's the cosine of half. Using that reciprocal idea again, and I can find those values on the unit circle. So which values am I looking for? Well, I want to know where the cosine is a half. Cosine's the x coordinate. I think we're looking at pi over 3. And I think we're looking at 5 pi over 3. I don't have an example to show you of this, but suppose I were to have gotten x values here from this factor as well. Then in my answer, I just need to make sure I list all of those options. You're ready to try a few more complicated equations now. And I've got one more piece to show you today, so make sure you stop back by in a couple minutes to check out the final video on today's work.